let's get cracking here. Haha, cracking the codes. My name is Josh Pelham. I am a strategic accounts manager at the Northwest Energy Efficiency Alliance. Welcome, everybody. Go ahead and go to the next slide if you don't mind. So for those of you all who are unfamiliar with NEA, I'll do a little introduction about who we are and then a little bit about what Better Bricks is, and then I'll hand it over to our presenter today. The Northwest Energy Efficiency Alliance is a nonprofit organization, and our mission is transforming markets. And we transform markets with the goal of accelerating the adoption of energy efficient products, services, and practices. We are an alliance of more than 140 Northwest utilities and energy efficiency organizations, and we work together on behalf of more than 13 million energy consumers. So we represent or comprise of organizations in Washington, Oregon, Idaho, and Montana. So we are able to do things through this, through that compilation of resources that would be really challenging for an individual entity to do just on its own. We are a third-party, unbiased organization that looks at energy efficiency opportunities, tests them, vets them, does research around them, and makes that available for the region to use. If an opportunity around efficiency looks good, we move forward with it. If it doesn't, we don't. So it really boils down to what we see. We vet and test these products, and again, we bring a real focus to the Northwest. And so a lot of the solutions that we test and vet and the information that we bring forth is really tailored and suited very well to the Northwest. Beyond, but particularly we have a Northwest flavor. Go ahead and go to the next slide. So what's Better Bricks? Be successful in our market transformation work, NEA manages a portfolio of market transformation programs, and these are all designed to leverage the power of markets. This includes commercial real estate, buildings. Certainly we all know that commercial buildings have a massive opportunity for energy efficient technologies to be adopted right now. But buildings, we tend to have a historic tendency to look at individual systems kind of independently inside buildings, but buildings really are a complex integration of these systems. And that's why we take all of our energy efficient programs that apply to commercial buildings and roll them up under our Better Bricks platform. So that's where you can go and find all of our resources around commercial buildings. Go ahead and go to the next slide. Whether you design, build, manage, operate, touch a commercial property or building in really any way, there should be something on Better Bricks for you. Better Bricks has been around nearly as long as NEA, having formed in 1997, and the first BetterBricks.com launched in 1999. So it has taken many shapes over the years, depending on what the needs of NEA's portfolio, the needs of the market are. And right now, with the introduction of building performance standards and other policies in the market, particularly in Washington and Oregon, we see a need to really revamp our efforts, double down on our efforts to support the market and adopting efficiency in their work around commercial buildings. So building owners, property managers, building operators, and facility staff, architects, designers, engineers, contractors, these are all the types of folks. If that's you, or if you are adjacent to any of those individuals, BetterBricks.com should have some resources. There's a lot's coming up over the next couple of years, a lot of plans internally that we're excited to share out. You can, again, visit BetterBricks.com to see the resources we have now. We're active on LinkedIn, and many of our videos, and including this one, which we are recording, are available at Better Bricks. That's our YouTube handle, so you can check out a lot of our educational resources there. All right, so that's a quick introduction about us. I'm going to turn it over to our presenter, Nick O'Neill, here shortly. As I mentioned, a couple of housekeeping things. We are recording this, and so this will be made available. It will be on YouTube. If you want to get this and any other information that we put out, if you want to make sure that hits your inbox, you can subscribe to our newsletter at betterbricks.com. Please ask questions throughout. Nick is indicated that he really likes an engaging presentation. So the way that we prefer you all to do that is if you look at the top bar, for those unfamiliar with the Teams platform, there's up at the top of the window there's a chat, and then there's a raise hand. You are welcome to input questions throughout into the chat or raise your hand. And what I will be doing is keeping an eye on that, monitoring, and I will interject as it makes the most sense, but we will have Q&A time at the end as well. So we may hold on if it makes more sense to do that. But please feel free to throw it in the chat, and we will be monitoring that. All right. Let me hand it over to our good friend Nick O'Neill with Energy 350, who is going to introduce himself and share a little bit about what we're doing here today and his background in this work. Take away, Neil. Nick.
Great. Thanks, Josh. Appreciate it. Good morning, everybody. So yeah, as Josh said, my name is Nick O'Neill. I'm with Energy 350. We're a EE consulting firm here in Portland, Oregon. I'm a mechanical engineer by trade. I got my start doing building design work here in, well, actually in the DC area, and then here in Portland for several years working on commercial buildings. So my experience with codes starts from the designer perspective of trying to navigate them and figure out how to comply with codes and dealing with permitting and understanding inspections and everything like that. And then for the past 17 years or so, I've been involved in the EE side of things, looking to make buildings more efficient. And so my experience with codes has now pivoted to making them more stringent or clarifying requirements, things of that nature. So I've seen it from both sides. I understand some of the complexities that go along with navigating codes and understanding what they are. And I'm hopeful this presentation helps clear a few things up about what codes are intended for, how the process works, the update process, and a little bit more about commercial building codes in the Northwest and beyond. Okay, so what we're going to cover today, we'll learn about the two primary model codes that form the basis for many of the state energy codes throughout the U.S., particularly the Pacific Northwest. Highlight a few similarities and differences between those, some key differences in how states go about developing and utilizing energy codes and what that process looks like and the frequency of that process, and then the general timeline for updating energy codes on a rotating basis. The second part of the presentation will talk kind of at a higher level about what codes are doing now and what they're likely to do in the future. What are some things we see coming down the road, how you'll interface with codes going forward. And then, talk a little bit about how NEA gets involved in energy code development, specifically in the Northwest for the two codes that we have here, but also elsewhere as it influences state code development throughout the states. So we'll begin with a little bit of a background. There are two primary commercial model energy codes to choose from. The first one we'll talk through is ASHRAE 90.1. That is published on roughly a 3-year cycle. It's a lengthy technical subcommittee process to add elements or remove elements from 90.1. You have subcommittees for HVAC and lighting, water heating, things like that, that will look at proposals, vet them through a subcommittee process, and then present them to the ASHRAE technical committees to get approval to roll into 90.1. Generally, it's thought to be the most rigorous technical process among the energy codes. There's a lot that goes into it before it kind of comes before the final code committee for adoption and rolling into the codes. And it's a lengthy document. It covers all the climate zones in the US. It typically has separate requirements for each of those climate zones if it's weather dependent or influenced significantly. For reference, the latest version of 90.1 is close to 500 pages when you include all the appendices and references and things like that. They do publish addenda between cycles. We'll talk about those in a minute, but that basically gives you a sense of what the next code might include. A lot of these addenda are elements that didn't make it into the first round of the code, but they were sound and ready to go, and they'll be rolled into future versions. So it's helpful to look at those to get a sense of what's coming down the road. And the important thing about 90.1 is it's really only intended for commercial or industrial facilities. It's not a residential-based code, although you've got residential occupancies that may be part of a commercial building where it does cover that. Now, by comparison, the other commercial energy code option is the IECC, the International Energy Conservation Code. That's part of a much larger suite of energy codes. Plumbing, gas code, mechanical code, energy code is one component. Now, that's also published on roughly a 3-year cycle, but it, of course, doesn't align with ASHRAE perfectly. They do offset each other quite often. Similar to ASHRAE, there are technical subcommittees, but there is an open public process to bring forward amendments. So really anybody from the public can submit a proposal to strengthen or weaken the energy code when it comes up for renewal. Those proposals are reviewed by subcommittees and are reviewed with group members before bringing to a full committee for a vote to include in the next version of the IECC. I think many understand it's not as rigorous as 90.1, but it has many of the similar requirements. There's a lot of similarities between the two codes, both in the background data that supports adding a provision, as well as the language and how it's written. The reason for IECC is really it's intended to be more readable by code officials compared to 90.1. As an engineer, 90.1 reads like a manual of, you shall do this, but for these conditions. And IECC is much more, common language throughout. And by comparison, it's only about 250 pages, so a lot shorter overall. It has separate residential and commercial codes. So unlike 90.1, there is a separate commercial energy code and a residential energy code that states may choose to adopt. And in our region, it serves as the model code or the base code for Washington, Idaho, and Montana, as well as many other states throughout the US. Quick note here, excuse me. California is sort of its own element. They use a state-grown code called Title 24. There are many similar provisions that you'll see in 90.1 and IECC, but it reads nothing like those two codes and really kind of is its own thing. So just to call out that's a separate process that we're aware of, and there's a lot of borrowing back and forth between different codes for that, but that does not rely on either of these to form the basis of that code. So quick note on errata, commentary, and addenda. Both IECC and 90.1 recognize that after publishing, there's likely to be a few errors in the language or missing references, things like that. They both publish errata, usually on a rolling basis, so that the most recent version includes all errors that were caught in a single document. IECC also provides commentary, a commentary document. 90.1 provides a user's manual. Those can really help designers and people navigating codes understand what the intention was behind a provision or clarify a code, sometimes provide an example to walk you through it. So those are helpful to understand. And they also provide, 90.1 provides interpretations as well. So sometimes if there's a really confusing element in code, somebody can submit a request for an interpretation and they will release an official answer to how you should interpret this provision that's in code, possibly fixing it in the future versions if the interpretation is correct. And like I said before, there are a lot of addenda that get published as part of the code. So helpful to see, what didn't quite make it into code this go round, but is likely ready for the next round. And that's a good way to look at future provisions that are coming in. And the addenda are can be pretty substantial. For version 2019, ASHRAE 90.1 2019, there were about 60 addenda, many of which were incorporated into the new 2022 version. And by last count, I think there was about 30 addenda in the 2022 version that will be incorporated in the following version. So quite lengthy documents overall. Okay, we're going to stop codes for a second and talk about federal standards because they play an important part in reading through the code. So quick note here is that the Department of Energy, the US Department of Energy, sets performance requirements for more than 60 categories of equipment. These are things like furnaces and boilers, water heaters, heat pumps. It's a lengthy process and it can often be delayed. In general, DOE is required to update these standards about every 6 years, but they're subject to delays for a variety of reasons, whether it's administrative or data to support the analysis or market pushback, things of that nature. And so some products have not been subjected to updates for quite a long time. What these standards do is they require that all equipment that's manufactured for sale in the US has to meet these minimum performance thresholds. There's often test procedures that go along with it. You can see in the display on the right here that they've got a test procedure referenced for heat pump there. That's the test procedure that all manufacturers have to follow if they're going to list their equipment for sale under this product type and a minimum efficiency associated with that. Now, the reason, I'm sorry, one last note is that after they are adopted, it's even several more years before they're actually enforced. So they do recognize that it can take manufacturers a few years to reconfigure tool sets and whatnot to meet these new requirements. So the whole process can be, 7 to 10 years from when a standard first starts to when it gets updated and enforced. And the real big reason to bring this up now is that state codes cannot require more efficient levels than these minimum performance standards. So they can create separate appliance standards or standards for products that aren't regulated by the federal government. An example of that is Energy Star might have a piece of equipment that has a test procedure, but it doesn't have a minimum efficiency level in the standard. And states can require that, but they can't go beyond that. That's a term we call preemption, and states are disallowed from requiring that. Now, I'll say this, and I'll provide some caveats to that later, but by and large, when you see these tables printed in codes, these are actual federal standards that are just copied into the codes for reference. Okay, so state energy codes. We talked about the two model codes, 90.1 and IECC, and what are state energy codes? State codes provide performance requirements, mostly for large systems, the envelope, HVAC, lighting, power density, things like that. They often do include those equipment tables, and that's mostly for ease of looking at one document and having everything there, rather than having a designer have to go reference the federal code of regulations for the efficiency level of a heat pump. It's all right there in the code so they can follow through. So that's why those tables appear there, even though they're not really governed by state codes. They're just referenced there. State codes often use one of those two model codes, 90.1 or IECC, to build off of and add amendments. And so you can see an example of one of the amendments here. This is the 2021 Oregon Energy Efficiency Specialty Code. You can see they've struck out a provision there and added their own language and underline. So this is a very common thing that a lot of state codes do. They will take that model code to serve as sort of the base template, and then they will modify things that are unique to their area. Enforcement can sometimes vary within the state. So Idaho has a state energy code, but local jurisdictions can decide whether to adopt it. And if they do adopt it, Idaho has a provision that they can't go beyond what the state has required. So they can't really take the code and go further with it. That's not true for all states, but in Idaho, that's one unique provision there. And I'm going to say a quick thing about dates, because you're going to see a lot of dates throughout this presentation. And when you look at codes, be careful with the dates. They don't correspond to the version of the document being used necessarily. So Idaho uses the 2018 IECC, but they call it the 2020 Idaho Energy Code. Likewise, Montana and the Washington State Energy Code reference the 2021 IECC. In that case, Washington aligns with it, but Montana just calls it the Montana Building Code. And here in Oregon, we use 90.1 version 2019. That's called the 2021 Oregon Energy Efficiency Specialty Code. So mainly just saying, don't get hung up on dates for what version of the code is being referenced. You really just have to look at, in the fine details, what version they are using as their model code there. So how do we look around the U.S.? This is just a relative level of stringency. You'll see here, this is by energycodes.gov. They have a reference to 90.1 versions throughout the U.S. These states do not use not all these states use 90.1. In fact, very few do. But it gives you a sense of stringency among the different states to show how the comparisons are. So you can see the Northwest, for Washington, Oregon, and Montana, we are at almost the most recent version of 90.1, which is 2019. That's the most stringent. Idaho lags behind in its stringency down to 2013. So I'll show you in a little bit later about what the stringency levels look like over time. But in general, the states here with the green are the most stringent, and those down in the orange or in the white that have no statewide code are the least stringent. When we look at our region in particular, the most stringent is definitely Washington. So Washington uses the 2021 IECC and then has a lot of amendments to it that are unique to Washington State. And once Washington sets its state code, the city of Seattle actually takes that code and then adds more amendments to it unique to the city, which results in about a 10% increase in stringency over that. So Seattle, you could say, is maybe the most stringent city with respect to energy codes in our region. And then going counterclockwise, Oregon has 90.1 2019 with several Oregon amendments. They will shift to the new 2022 version next year, starting in January. Idaho references the 2018 IECC with several amendments, and then Montana, the 2021 version of IECC with Montana amendments. And we'll talk about amendments coming up. So let's talk about a couple of the similarities and differences between these two different codes. If you are looking at 90.1 as your code, so here in Oregon, 90.1 is our reference code, you're going to look at compliance paths. And most of the projects that come through code use the prescriptive path, which is follow a set of mandatory requirements and then another set of prescriptive requirements. I think that's what most designers are used to doing for general buildings that they work on. But if you're not going to prescriptive, you have to use one of the many performance path options, and you can see here listed on the right. Now, performance path, allows some more design flexibility. If you've got a complex building type that doesn't quite fit in the prescriptive path, modeling can help, really tease out the compliance for that with energy code. It allows for a lot of trade-offs. So code has a lot of stringency on things like window to wall ratios, where you can't have more than 40% glazing compared to your wall. Well, obviously, you go downtown, you can see a lot of buildings that are, look almost 100% glass on the outside. And one of the ways that those buildings can comply is they can trade off for better HVAC system or lower lighting power density. So they can use that model path to say, yeah, we're going to put more windows in, but we'll make the building more efficient with other systems. And on a net basis, that will be equivalent to what you would have required otherwise. Also, buildings that look for like LEED certification or other green building designs and want to capture the credit for going beyond code, they can use a performance path to demonstrate that. And some of the drawbacks are really time and cost to develop the models. It takes quite a bit of time to develop the models. It takes even more time to QC them for those that work on energy models. And it can be difficult for code officials to really understand the models if they're not familiar with the variety of modeling software that designers might use. So there could be a lot of back and forth during the permitting process on what is meant by this this feature that you've put in here, having to dive into the model details. So one of the reasons is just the complexity of that, and then the time it takes to build a model and review it. Now, IECC, by comparison, actually allows compliance. One of the paths is to go with 90.1. So if you are in one of the other states, Washington, Idaho, Montana, you could actually follow 90.1 and demonstrate compliance through IECC. They also have a performance path, the total building performance path. That's one that looks at modeled energy cost and ensuring that it's at least 80% or less than a reference building would use on an annual basis. And then similar to 90.1, it also has a prescriptive path. It has a set of prescriptive requirements that have to be met to comply with code. But the feature that it has that ASHRAE has not had for some time is this additional credit section in C406. And what this section does is it allows buildings to choose from a variety of possible efficiency measures to comply with code. And the key here is that they have to obtain a total of 10 credits from this section. So let's look at what that looks like. Here's a snapshot of one of the occupancy groups in this table. So they have, this table exists for all different occupancy groups with different credit values associated for each of them. And like I said, new buildings need a total of 10 credits to comply with code. So they can do that through a combination of measures. As you can see, for a typical office building here in a Northwest climate zone, which is 4C, you would need 2 or 3 options to meet those 10 credits. So here's one way you could do it. You could improve your cooling efficiency. You could look at your envelope performance and also your reducing your air infiltration. That could be one way you comply. You could see right next to that in climate zone 5A, you would only need to do something associated with the envelope to meet the 10 credits. So it really depends on where your building is located in the climate zones and how much credit is given to that measure. Now the credits are intended to be based on equivalent energy savings across the building types. So IECC has done a lot of modeling, or really the labs have done a lot of modeling to support IECC on what's the equivalency of this measure when you look at it in different climate zones in terms of how much energy it saves. And this provides a lot of flexibility, but also obviously adds some complexity of how do I, comply with code and what are all the things I need to do here. Now I'll point out that one one interesting feature here is this cooling improvement and heating improvement. The first two lines, or the first three lines really in here about efficiency improvements. Because you'll remember, as I said before, you can't have a state code require a more efficient, cooling or heating system than a federal standard requires. And we know there's federal standards for cooling and heating equipment. So I'm going to talk about that in these other examples. So here's an example, and don't worry about reading the text on the left. It's just a snapshot, but to see how the different codes, phrase very similar requirements. So this is an example spec for an economizer in ASHRAE 90.1. And the way 90.1 really lays out their text is that this provision is required unless it's specified by one of these conditions listed below. So they just say that you have to have an air economizer, and then they provide reasons why you might or might not have to include those. And you can see there's one that's circled there that talks about if you have a cooling efficiency that exceeds that listed in the table, depending on the climate zone. And that's a snapshot of the table there. So you can see in our climate zone, we've got for 4C, if you had a cooling system that was 64% more efficient than the federal standard, then you would not have to provide an economizer for that. Now, that's obviously looks like preemption. You are requiring something that's greater than what the federal standard is. But the way codes get around this is that this is an option. It's not mandating that a building has to follow this or a designer has to follow this. It's providing it as an option. And by doing so, both in this provision in code as well as the table that I just showed before, you are giving a builder the option of providing more efficient equipment without requiring them, and therefore you're not running afoul of federal preemption requirements. So that's really the only case that I've seen in codes where you can do that, where you can require something better than what the federal government requires for manufacturing, is to have it as an optional path to take. Okay, so this is the same requirement, but written in IECC. So you can already see it's a little bit plainer language, a little bit shorter. The way IECC looks at economizers or looks at provisions is really to specify where it's needed and then provide some exceptions for special cases. So instead of providing an economizer for everything, but for these cases, it tells you where you want to include it. And you can see that it has this same exception here for systems that exceed the minimum efficiency requirements. But what you'll notice right away is that the levels are much lower. And it doesn't even include all the climate zones. This isn't a truncated table. This is the only table that appears. So they really only see in these climate zones a reason to have better cooling efficiency. And at the maximum, it's 20%. So it's nothing close to the 64% that we saw from 90.1. So same exact provision, different code, different requirements here based on on what they see as the most important feature to follow. And then we'll take something like a state energy code. So here's the Washington State Energy Code. Like I said, this is IECC based. It's written a little bit differently than both codes, but the approach here is closer to 90.1 in terms of its stringency. You can see that same exception is required there, and they limit it to the only two climate zones in Washington, 4C and 5B, and the efficiency improvement lines up with 90.1, but it's written in IECC language as an exception. So you really get kind of this kludge of model energy codes, stringency requirements, where they came from, and then how they are displayed once you get to the final end product of an energy code. Let's talk a little bit about what this update process looks like. So we talked about the model codes that go under development and then the state codes that amend them, but kind of what does this process overall look like? So in general, it takes over a year from the time a new code is considered, excuse me, until it's adopted by a state. It goes through a proposal development phase. That's what we talked about before with public input or subcommittees that develop proposals. They bring those to the code agencies. There's a comment period where the public is allowed to review sort of this integrated draft version of the code, make comments on it, provide feedback and changes. Once that's done, almost 6 months to a year later, the code may vote to adopt it and set an effective date after approval. Typically, there's a 6-month date from the time a code is set to be effective to when it's mandatory. So there's a sort of a grace period where buildings can choose to use the old code or the new code, and then after that 6-month grace period, they must use the new code. It gives a little bit of time in the market for people to become familiar with it. It also gives time for training for code officials and for designers. Things that Nia talks about before on Better Bricks is that there's a lot of work that goes into training the market for what the provisions are from the new code to be aware of. And then once the code is adopted and mandatory, there's a whole compliance and enforcement period where they look at plans examiners and building officials to understand what's working and what isn't in code here. What can we fix for the next version around? And this provides a pretty consistent time series here where you're either finishing up the new code or you're working on the next one, because after a few years, on a rolling 3-year cycle, there isn't a lot of lag time between ending one code and starting another. And this all assumes that there's no substantial issues occurring along the way, which could derail it, whether there's a problem with code adoption, whether there's a lot of pushback in the market, whether there's a pandemic. All of these things kind of play into this code development timeline. So that's in general. Let's look at sort of the code update process from the model codes and the state energy codes and kind of how they play with each other. So we're going to start with the release of a new national IECC. Now, like I said, these happen on 3-year bases, and we'll say that this new model code is released. Once that's released, Washington State usually is the first one to start looking at integrating that model code into their state energy code. So they will start reviewing proposals, incorporating that into an integrated draft version. And then at the same time, California will be rolling along with Title 24. Now, as I mentioned before, that's a completely separate process, but California has a lot of firepower behind development of code proposals, and they do a lot of stakeholder outreach and engagement for their code. And they develop these case studies, and a lot of those case studies are translatable to other energy codes. And so oftentimes, a lot of the provisions that have happened in Title 24 from the last round of codes will be used to help inform EE proposals for the Washington State Code. Now, once all that's integrated there, Washington will go ahead and adopt the IECC model code plus their amendments, the Washington State amendments to create the new Washington State Energy Code. And like I mentioned before, Seattle will then take that code and usually tries to go about 10% better than that. Now, sometime along the way, the new version of 90.1 is released. Like I said, these aren't exactly on a 3-year cycle with each other. They're offset somewhat so that the timing is sort of less relevant, but it happens not at the same time as IECC. But what is important is they also will borrow from Title 24 as well as give back to Title 24 for a future code version. So there's a lot of info sharing there. And likewise, depending on the release schedule, it may provide some fodder for Washington State and vice versa. Washington State's code provisions may provide some input to 90.1. So it's a real big info sharing party here between the different code versions, depending on when they're released and what's ready in time to use. At some point down the road, 2 years or so, that IECC national code will start reviewing proposals for the next model code and start the process all over again. And then similarly, they're going to borrow from whatever has been developed before, either with 90.1, Title 24, Washington State. After 90.1 is released, Oregon will add its OESC amendments to it. And then they will adopt a new version of that after DOE certifies 90.1. That's sort of a technical piece that has to happen where DOE looks at all the provisions and the savings from that and certifies the compliance software related to 90.1. That's when Oregon officially will adopt it. Now, along the way, there'll be addenda and errata that are included in there. I'll note this later on as well, but Oregon will adopt all the errata, obviously, to correct mistakes, but it does not adopt the addenda unless specifically called out. So addenda that are released from 90.1 don't automatically go into the Oregon Energy Code once they are, released by 90.1. And then we'll kind of continue the process. It starts over. Another national IECC model code is released. And at that time, Idaho and Montana may choose to adopt those IEC versions or previous versions and add their own state amendments. All right, so we're going to dive in a little bit to the individual energy codes here and what they look like. So as I mentioned already, Oregon Energy Code is the OESC, Oregon Energy Efficiency Specialty Code. All of its codes, including building, mechanical, plumbing, they're updated every 3 years. Now, Oregon refers to this as the OESC. It's actually Chapter 13 of their Oregon Structural Specialty Code. That's a mouthful. And like I mentioned before, they use 90.1 as the model code, and then they provide us this small 2-page document with amendments. So up on the right, upper right, you can see a snippet from that document. It's on Oregon's Building Codes Division's website that has the provisions that are in there. And previously, they used the IECC as the base code, and they had a process that was more similar to Washington, where it would take that and do a lot of amendments. Now there's only a few amendments to Oregon's energy code. But as you can see here, here's another example. This Oregon adds this new section here, 64351. That doesn't appear in the 90.1 base document. And so if you, as a designer, if you were to just go to 90.1 and look at the provisions there, you wouldn't find this. You would have to use the Oregon Energy Efficiency Specialty Code kind of overlaid on top of that to see where the changes might be. Now, Washington State has the State Building Code Council. They oversee updating Washington State energy codes. Just to note, Seattle is updated by a separate entity, the City of Seattle's Department of Construction Inspections. They're in charge of updating the Seattle Energy Code after Washington updates its state code. And then similar to Oregon, they update all their building codes and energy codes every 3 years or so. There's also this 6-month grace period, usually after the code is adopted, before it's required by designers to use it. And unlike Oregon, code proposals here go through several rounds of review by advisory groups. So you can see over on the right, there's technical advisory groups for building code, fire code. I have the energy code one pulled up. So all these tag groups take a look at the proposals, the information that's used to support them, and go through and look at the provisions. The 2021 code had over 100 proposals that they reviewed. That's reviewed by the Energy Code tag. It's then reviewed by the Mechanical, Ventilation, and Energy Committee. And then once it passes both of those stage gates, it's moved on to the full state council for approval. And once that's done, then it can be adopted. And then Idaho, Montana, they use the IECC model codes, and they add some amendments to them. Montana amended the 2021 IECC, and Idaho amended the 2018. Historically, they've been a little bit behind the adoption of IECC by a few years. So Montana actually skipped the 2018 version and went right from 2015 to 2021. Similar to the other states, they have a public input process. In Idaho, they have a code collaborative group, and that group has volunteers from the state and the county and city representatives and other stakeholders, and they use that as a public sounding board for code proposals that are developed mostly by the code officials there. And then Montana hosts listening sessions throughout the state where the public can come in and voice support or opposition to proposed changes in the code. Now, some amendments, like the one in Montana, are mainly administrative and related to enforcement. So you can see the top right there. Montana's administrative rules has a couple of provisions in there about how the code is authorized and how do you comply with it, but they're not really striking out language from the IECC and adding their own language for separate code provisions. Conversely, Idaho has done that in a few cases. There's not many, but there's a few areas where they've actually added an exception in here in this case, which might weaken the code, allowing more or less stringency on when an economizer might be required. So the proposals can go both ways. It doesn't always result in an increase in stringency of the code, depending on the unique nature of the state and the provision. Okay, so that's a lot on the code process and how it's updated, but let's level up and talk a little bit about the broader picture. So how NEA interfaces with codes. Mentioned a little bit already, but NEA helps support the code development through proposal writing and analysis with market partners. They do that for both the state energy codes as well as the national model code, the IECC. So here's an example of a proposal to amend the demand control ventilation for kitchen exhaust hoods. So they'll help support the writing of this proposal and any data to support that to bring before the energy code tag in Washington. They also provide resources to assist with code development. So you can see here in Idaho, they have a ventilation effectiveness study that they produced that's on the Code Collaborative website, so people can look at that and use that as a resource when they're developing code proposals. And then one of the biggest things that NEA does is they provide training. So They provide training to code officials, Better Bricks audience like we're talking through today, builders, utility programs. We've done code trainings for architects and engineers and design consultants as well. And then they also help develop tools to assist with compliance. So in Washington especially, there's a lot of software tools, Excel workbooks that can be helpful to demonstrate compliance with the energy code here, and NEA helps support that through funding. Now, how they actually support codes is they really help focus code proposals on ones that have high impact and provide clarification. They also help provide analyses from field trial demonstrations. NEA works in the market. They help fund field trials. They do market analysis, and a lot of the information can be boiled down to help support a code proposal. There's one example here on Better Bricks itself about the Washington State Energy Code requirements for DOAS systems and how that compares to NEA's program for a very high efficiency DOAS. So that's does a comparison between what's required by code and what their program requires, and what are the key takeaways there. So that's a really helpful resource for somebody that's trying to navigate through the codes and understand, how are these different and how am I going to comply with this? They also fund analysis to estimate savings from code impacts. So they look at compliance studies. They do an evaluation to say, this provision is likely to save this much energy. They help fund support for doing those efficiency credit tables to look at what's the, relative energy savings across different climate zones and for different building types, to make those a little bit more of a fair analysis in code. And then they help move a lot of these market-ready programs into codes, through market transformation efforts. So things like heat pump water heaters that have been out for quite a while and are commercially viable option can now move in energy code with a lot of analysis and market data to support that. And then finally, they help conduct a lot of compliance and evaluation studies to understand what the impacts of codes are after they've gone into effect and been in effect for some time. Okay, so that's a high level. What do we got coming down the line for codes in the future? So start with 90.1. There are a few changes in 90.1. So use of mechanical system performance rating, which is another mouthful. TSPR is another way. Total system performance ratio is of what we've heard in the Northwest for Washington State Energy Code. It's based off something very similar. And that really focuses on optimizing the mechanical system performance. And the way it does that is it looks at the annual heating and cooling load of the building to the annual energy consumed by the building's HVAC system. And so you want a better ratio than a reference system might provide. So this is very similar to how a whole building approach might be done, where you're looking at a proposed building and a reference building, and as long as your proposed building is more efficient, then it complies with code. But this is really dialing in on the HVAC system itself. Instead of sort of the disparate components that make up an HVAC system, it looks at it as a system as a whole and how it performs compared to how it would perform in a reference case. So that's another performance path that's coming. The big thing in 90.1 version 2022 is this adoption of energy efficiency credits. So as I mentioned before, IECC has had these for quite some time. They've existed in the residential code for a long time, but now 90.1 is going to include them in the commercial code as well. So as you saw before, it's going to look very similar to, or does look very similar to IECC, where they've got different climate zones and building types, different credits associated to those. It'll provide more flexibility for a designer to meet code. Like I mentioned on the previous slide for DOAS, now if you do a DOAS system that's more compliant with very high efficiency DOAS that NEA supports, that is an optional compliance path within this energy credit table. And IECC 90.1 based this on cost equivalency. Washington actually bases it on carbon. So just a note there, if you're looking at the tables, the credits that you're assigned for these different options are look different, even though the options themselves are pretty much standardized across all of the model codes and state energy codes. So where do codes go from here? This is a little bit of my take and a little bit of what we've seen kind of through the code proposals. So we'll continue to find some small fixes in prescriptive path to reduce energy use. There's not a lot of low-hanging fruit left for new buildings, and there are some limits for alterations. You could increase the insulation level on piping and ductwork, but you're going to run up against some practicality limits in the space that's in an existing building, and the cost to do that kind of work. So code understands, or the people that provide code proposals understand that there's sort of a limit to what we can provide there. There'll be more stringency and specificity on controls. I see that as a big area in codes that's going to come out down the line, is getting a little bit better about like what the control features are that are required in units, piece of equipment, some more integration with those controls in systems as well. Some of the progressive codes might also, or will also, start focusing on other benefits. So water is a big issue in California. So California's Title 24 is looking at kind of the water energy nexus and understanding what the benefits or drawbacks might be from energy use as it impacts water use. And in Washington, they've already got a focus on carbon. EUI targets are going to become, I think, a bigger part of code, especially as these states adopt these building performance standards that are looking at reducing EUI levels. I think there'll be some alignment between what code is trying to do and what the state performance levels are trying to do to make it easier on designers overall. I'm sure there'll be some expansion on energy credits. There'll be, different flexibility options. Maybe some will go away that aren't really utilized very often, or modified to better fit kind of modern day technology. And where I really see it going in codes is focusing on processes that were maybe more unique and uncovered in the past. So we've already seen this with data centers. 15 years ago, data centers were pretty much exempt from all codes because they were seen as a process load. And over the years, codes have tightened the screws on that to make them exempt in certain situations and for certain parts of it, but that there still is some requirement for data centers to become efficient. And horticultural lighting is the newest one, where there's now provisions in code for lighting levels and likely dehumidification levels and things like that. So more nuanced processes are likely to make their way in. I also see a lot more focus on controls and the system operation versus the specs. So like I mentioned before, I think lighting controls and HVAC controls are going to see like greater requirements being needed there. Chiller plant monitoring is something that's come in, DCV, demand control ventilation, that's separate by climate zone, and the use of energy recovery and some other control elements for smaller equipment. And I also see some other performance path options. So we've got this TSPR, mechanical system performance ratio for HVAC. Could be something else for other systems as well, whether there's something for surface water heating or other process loads that are increasing in operation. I could see that as well. I get asked this a lot. Are codes actually getting easier? And in some ways I could say, yeah, they are. There's a lot of work that goes into, increasing clarity and requirements that reduce the burden on designers. It may not seem like that, but there's a lot of times that people debate over commas and the word or included in code proposals, because something as small as that can have a big impact on how people interpret the code. And so there's a lot of thought into how do you write this so that people can follow this, designers can follow this. I think there's generally an alignment that's happening with 90.1 and IECC. If you are a designer that works in Oregon and Washington, Oregon and one of the other states, you've got two different model codes that you're looking at, and it's really confusing to keep track of what provision works in one state but doesn't in the other. And so it's helpful to have some more alignment coming down the line. More builder flexibility with those additional credits like we talked about. And then most codes have this simplified path to allow smaller or less complex buildings to comply with code without having to go through every single section. So that's definitely a step in the right direction for making the codes easier. But I also say that no, they're not always getting easier. Systems and control requirements are getting much more specific. One point is there's more integration between the trades. So lighting and HVAC have some integration here, especially as we look at sensors to look at occupancy and how that ties into ventilation and heating and cooling. So there's some more complexity in the design element of code, or a design element of building that to comply with code. There's also more options like we talked about, but that brings some confusion. How exactly do you comply with code? If you've got a table of 20 options and you've got to hit 10 credits, well, it's not just a straightforward path anymore. You've got to really think about that. So that can bring some complexity as well. Probably more focus on alterations in the built environment, which is going to bring some complexity with that as well. Trying to make things work in a building that was built 100 years ago can bring some challenges. And then, I do see additional compliance paths being helpful, but A lot of them are going to be performance-based. It's going to require a lot more, time and money to go through that kind of design versus the prescriptive path. So just to bring it all home, how are we doing? Here's a look at estimated improvements in commercial energy code over the last, almost 50 years. So from mid 1970s, if you look at a building that was built to ASHRAE, version 1 in 1975, at a reference of 100 kBtu energy use, well, all the way over the right, we're down to about 39 kBtu. So pretty substantial savings, year or not year over year, but 3 year over 3 year improvements in energy codes over time. We're doing pretty good, but we've still got a ways to go. And to wrap it up with why do we even have building energy codes? Well, obviously you want to improve the efficiency of a building and reduce the associated greenhouse gas emissions of the building stock. The broader picture here I see is that if buildings were allowed to just use as much energy as they want, not only would that cost to be passed down to tenants of those buildings, but also utilities would need to build more generation resources, and that pushes the cost down to the ratepayers, you and I. So it's a key reason why efficiency helps keep rate lower than they would be otherwise, and buildings play an important part of that. They're also a critical part of state building goals here. You can see over on the right from Commission report to Oregon back in 2015. The yellow slice there, residential, commercial, industrial energy efficiency, is a big slice of that. Moving from business as usual down towards the target, and so building codes are a big slice of that piece as well. And then finally, just leave you some resources here on where you can find more technical assistance for each of the 4 states in the region. There's a lot of good contacts out there. If you've got technical questions as you go through energy codes, interpretation issues, contact folks here. They're very responsive in getting back to you and providing an explanation on how you interpret something and what they meant by this provision. And so with that, I will turn it back over to you, Josh, or if there's any questions, I can stay on and answer. I think we've got a couple minutes left.
Thank you, Nick. As somebody, that was the deepest dive I've been through around codes, and I must say that that's a lot. That is a lot. Thank you so much. And as far as these resources go, and Michael, I see that we'll get to you really quickly. We will send out a link to this recording, which will also go to a page where we have this listed on betterbricks.com. We'll send that to everybody here. Michael, why don't you go ahead if you want to come off mute and share your question with the group.
Thank you very much for the thorough presentation. It's a quick question, I hope. I've got a 10 o'clock, so hoping it doesn't go past that. In 24, early in 24, I'm an architect. I renovated a prefabricated steel building, a Butler steel building in Eugene. And it was non-conditioned space, and I essentially made it a conditioned space. It's around 28,000 square feet in size. At that time, I learned from my local building department and then subsequently working with the top energy official at the state, there is no ASHRAE code path for essentially retrofitting a metal building or a tilt-up concrete building because of essentially the continuous insulation. It's called like linear insulation in ASHRAE. Mm-hmm. But essentially what it would mean is, in very simple terms, in order to meet the ASHRAE code outright, you would have to strip off all of the metal siding and roofing, put in like a compressed rock wool, for example, and then reinstall it. No one's actually going to do that. Mm-hmm. And I forget the gentleman's name that I was working with at the state, but he recognized the reason that the City of Eugene Building Department can't approve this is because there literally is no path. My building department was saying build a box in a box, which was asinine. I was not going to do that. And so we subsequently found a path, but it was very far from prescriptive. And the gentleman I was working with at the state was saying, don't even try to deviate from prescriptive because it's just too complicated and too expensive.
Hmm.
So my question is there a code update that is going to be addressing this that you're aware of by chance?
That particular issue I'm not aware of. It could be in 90.1 2022. So you can look at the amendments on ASHRAE's website and see if there's one in there. I'll say that the amendments on ASHRAE's website are not the most user friendly. There's not like a index of something you got to look for. You just have to go through each one of them and see. Luckily, there's only about 20 or 30 right now. But what I'll say is that with any of the code paths, the buck really stops at the code official. So they have the authority in almost every state, I believe, to waive requirements, provide exemptions, things like that for the code. So they adopt this energy code, but if you prove an extenuating circumstance where you're trying to do something that's very outside the kind of normal bounds of a prescriptive path, code official is your best bet at navigating that.
I tried that path actually, and and
you might not always like the answer, but
yeah, and so I ultimately went above my local department because the person that they reach out to is the person I reached out to. And so I just basically shared communications from the state and they subsequently approved it. But
gotcha, yeah.
That's sort of like the sausage making. It's more and more we're going to be doing these because there's a large building stock that exists. And as we do tenant improvements on them, some of these spaces need to be conditioned.
Yeah. So what I'll say is if you go to you see the BCD website up here, the 2024 Oregon code, which is based on 90.1 2022 is, almost sealed and done, will take effect next year. But Blake Shalide is a good resource there to bring these questions up to them about, hey, I see this as a growing issue and we'd like to get this adopted in the next code. And like I mentioned, even if 90.1 doesn't pick it up, Oregon could pick it up as an amendment, or if they see it as a unique feature in their state, they could address that through code proposal. So I would definitely look to the the experts there to make your voice known.
Thank you very much. I have a 10 o'clock. I'm going to boogie. You guys have a wonderful day.
Thank you, Michael. And thank you, everybody else. We are at time and we want to be respectful. So this will be coming out to everybody. If you have follow-up questions, info@betterbricks.com. Nick, if you want to go forward in your slide, Nick's email is here. jpelham@nia.org is, you can get a hold of me directly. Thank you all so much. And hopefully we see you on the next one. Take care, everybody. Have a great holiday.
Thanks, everybody.